Hi everyone, I'm going to demonstrate to you a heart rate monitor that I've built. So what you see here is a pulse sensor that basically when you place your finger on here, it senses the pulse signals and sends it to a microcontroller out here. So the microcontroller does some processing of the signal, and it's also got a Bluetooth chip in it, so it sends out the data values, sample values after processing via Bluetooth. So on the other side, there is an app that I've built which connects to the Bluetooth device out here, and it reads all the signal data that's coming in, and it just does some more filtering on top of it, and it calculates the heart rate for you and displays the heart rate. And there's a battery inside as well that's connected to the circuit that powers the whole thing, and there is a tiny little switch here that can switch the circuit on and off. So I built this case and 3D printed it so that it holds all the equipment together and fits in pretty snugly, so that things don't move around, and it's a nice good fit on your hand. So let's go ahead and power on the circuit. Just flip the switch, so that turns the circuit on. There is a cover to this as well to prevent light from outside, interfering the pulse sensor light. So you fit this thing in. So you see here, the pulse sensor is inside. Just slide in your finger like this, and it starts reading the pulse signals and starts emitting by those signals by Bluetooth. So the microcontroller is processing the pulse values and sending them out via Bluetooth, right? So this is the app on the phone. I just connected to this device. So now it's connected to the Bluetooth chip in here, and right now it's doing some calibration, processing some values, and very soon you'll see the data that's coming in. So yeah, so that's the heart rate that is coming in. So those are the pulse values, and it's plotting them out in real time and doing some calculations to figure out your heart rate. So it's right now fluctuating a bit. So yeah, around 80, 79, 80. That's it. So let's see if it is correct or not. So what I have here is another app. There are lots of apps out there on the Play Store. This is that measure your heart rate, right? So this one uses the camera and your flashlight to measure your heart rate. So yeah. So let's just place my finger here, and it's searching for my heart rate. 87, 88, and the app is showing 92, yeah, 83, 81, 86. So yeah, 80, 86. So if you're curious how this works, so basically you have the pulse sensor. So when you keep your finger, it's reading some pulse values, float values like 500, 555, whatever, and those are values are reading into the microcontroller. Right? So the code that I wrote on the microcontroller, basically first it does calculate kind of the gradient of the signal. So basically it subtracts two consecutive samples and kind of sees the rate of change of the signal values, and it applies some noise thresholding, so ignore values that are very small, right? And then it passes it through a median filter. Median filter is basically for every sample it looks at its neighbors, the like two on the left, two on the right, and it calculates the median of these values and takes that as the sample value, right? So it does median filtering, and then it basically just transmits the values in as a float array. So this is basically actually sampling at 25 samples per second. So this thing collects 25 samples, does some processing, and then sends them out. So every second you get 25 samples. So the chip itself can only send 5 samples at a time. So there is some I wrote some code for batching the packets together. So when you want to send 25 samples, it just sends out 5 data packets, right? So on the app side, the way it works is this is receiving 25 samples every second, right? So what you see here right now is just a snapshot of the app in action. So this one uses 10 seconds of data, so like 25 samples per second, 10 seconds is 250 samples. So it processes 250 samples at a time. It just does some more median filtering on the data, and so it just get a bit more cleaner signal, right? And then it plots out the data for 10 seconds in real time. So the window that you see here is basically 10 seconds worth of data of here. And it's basically every pulse, every heartbeat is correspond to a peak here. So basically it counts the number of peaks to calculate your heart rate. So the number of peaks here gives you the beats in 10 seconds, multiply that by 6, and you get the beats per minute. And so that's kind of what shows up here. So actually this also, the app also does a bit of smoothing of the heartbeat values. It maintains a history of the last 5 values that it calculated, and then just takes the mean of that, so that the values change more smoothly. So yeah, that's how it works. Thanks for watching.